Before we start it, we should always make sure we have a 1 in front of the x. We divide by 2, we get pi over 2. So it's actually pi over 2 to the right, not pi to the right, which makes a difference, yes? The amplitude from an equation is the absolute value of a, yes? So it's the absolute value of -3, so my amplitude is 3. The period is 2 pi divided by b. The reason why it's 2 pi is look at our c value. Our c value is in radians, correct? If our c value was in degrees, we do 360 divided by b. Okay? So it's 2 pi divided by 2, which is pi. And remember I told you that normally it's set up to be 2 pi, but we have a horizontal stretch by a factor of a half, correct? So half of 2 pi is pi. You can verify it that way as well. The domain of every trig function is XER in set notation, or negative infinity to positive infinity in interval. To get the range, we need the max and the min. And we want to find the max and the min without our calculators. So remember, if we find the midline, what's the midline? Y equals 7. So we have a middle line here. It's at y equals 7. Correct? The amplitude is how far up and how far down you go from that midline, correct? So the amplitude, we are going to go 3 up from 7. So what's our maximum at? 10. It's at d plus amplitude, down. Down's good, remember? So we get a 10. And then the minimum is d minus our amplitude, right? Because we're going to go 3 down. So it's going to be at 4. So I don't need my calculator to get those. And if they're variables, you can't use your calculator to get those. So we need to know that we take our midline and we add our amplitude to it, or midline and we subtract our amplitude from it. So our range in set notation is y such that 4 is less than or equal to y is less than, or these are slanted L's, low to high. 4 to 10, right? YER. Interval notation is easier. You just go square bracket because it's equal to 4 comma 10. Yeah? Okay. Transformations. We're in trouble if we do not take that 2 out. So I'm just going to state the transformations because we're going to move on to more questions. So the transformations we have are vertical stretch by a factor of 3 about the x-axis, horizontal stretch by a factor of a half about the y-axis. We have a reflection in the x-axis. We have a horizontal phase shift, pi over 2 to the right, and a vertical displacement 7 up. So we have to remember the phase shift and displacement words, right? And our mapping, we have x, y, x's be crazy, so they switch from equation to mapping, but mapping and words are the same. So we're going to get 1/2 x plus pi over 2, comma, negative 3y plus 7. Yeah? Okay. So that's one from this chapter 5, right? Now we're going to do one from chapter 4. Ready? I want exact values, which means unit circle, right? That means unit circle, yes? Are 15 and 75 on the unit circle? No, but their friends are. For example, 15, you could do 45 minus 30, but then you have to go to your formula sheet, to the minus formula, correct? Not distribute. You do 60 minus 45. There's numerous options. 10, what do we try and stay away from? 30s. We try and stay away from 30s, because 30s end up being root 3 over 3, which gets you fractions in a fraction. So we try and do 60s. 60-degree reference angles. Right? So tan 175, or 75, sorry, I would personally do 135 minus 60. Stay away from that root 3 over 3, because 60s are root 3s, right? Those are nice ones. Sine of 15, we could use sine of 60, no, I don't want it. Sine of 45 minus 30. If you did a different one, should you immediately erase now and just say, I'm done? Might as well cut my losses.
Nope.
No coming back from this. No, you shouldn't. All right, so the sine minus formula is sine A cos B minus cos A sine B. So we're going to get sine 45, sine 30. Nope, cos 30, right? My brain is halting between the formulas. Cos of 30. Minus cos of 45, sine of 30. All right. So, sine 45 is root 2 over 2. Cos of 30 is root 3 over 2. Cos of 45 is root 2 over 2. Sine of 30 is a half. So, we're going to get root 6, because remember radicals, outside times outside, inside times inside, right? Coefficient times coefficient, radicand times radicand, over 4, minus root 2 over 4. You should always get a common denominator. If you don't have one, you messed up. Root 6 minus root 2. Please. Don't write that as root 4 and then make it a 2, and then all of a sudden it's not true. It's not real. It's like everyone gets to here and then you keep going. No. Stop. And remember, these can be checked. Go sine of 15 in your calculator. Make sure you're in degree mode. Let's go. You're probably in radian. So go sine 15 in degrees. Sine of 15 in degrees. Okay. Then go root 6 minus root 2, enter, divided by 4. Doesn't matter, because unless you're pressing sine, cos, and tan, it doesn't matter if you're a degree or a radian. Do you get the same decimal? So, do you get the same decimal? Yes. Oh my land. Okay. Now tan A minus B, what I'm using. So you go tan A minus tan B. Yeah. Yes, I got there. We got there a while ago. 1 plus tan A tan B. So we get tan 135 minus tan of 60 over 1 plus tan 135 tan 60. Okay, tan 135. That's here. When I do sine divided by cos, what do I get? Negative 1. So I'm going to get negative 1 tan of 60 is minus root 3 over 1 plus negative 1 times root 3. So I get negative 1 minus root 3 over 1 minus root 3. And then I have to multiply by the conjugate, correct? To make the denominator not have radicals. That's what you're taught in 20-1. 1 plus root 3. 1 plus root 3. The reason why you multiply by the conjugate is to get rid of the radicals in the denominator. So if you don't, you messed up. So we're going to get negative 1 times 1 is negative 1, minus root 3, minus root 3, minus 3, all over 1, plus root 3 minus root 3, so those cancel, minus 3. So I'm going to get negative 4 minus root 3 minus another root 3 is minus 2 root 3s over negative 2. What can I take out of all 3? It has to be out of every term or not at all. What can I take out? Negative 2. I can take out a 2, but I'll have to put a negative 1 on the bottom, which they won't leave. So take out a negative 2. So you're going to be left with 2 plus root 3 over 1, which I don't have to do. So put 2 plus root 3 in your calculator. So sad. That's whiny. 2 plus root 3 in your calculator. Then what else am I going to make you put in your calculator? Tan 75 in your calculator. Make sure you're in degree mode. Oops. Degree mode. It's the same answer. Wow, except this one's exact and the one you have on your calculator is not. So don't go try and hand me a decimal answer. That just meant you typed in your calculator, did nothing. Not good. All right? Okay, try this one out. So you need to draw 2 triangles, correct? I'm giving you guys actual information. So cosecant goes with what? Sine. Sine is what? Your resume. So this one is resume your. Catch, can resume be negative?
No.
So where does that negative have to go? Then I have cotan. Cotan goes with tan. Tan is what? Tan, your x box. So this is x box your. We don't know if the x needs to be negative, if the y needs to be negative. We need to draw it first to find out where it needs to be, correct? Draw 2 triangles. There's a triangle x and a triangle y. And then we need to use our formula from our formula sheet to expand that out. 3 pi over 2 and 2 pi. I draw my triangle when they give it to me. I label it as x because this is cosecant of x. Okay, they told me y is negative 5. R is 17. I need to get x, which is positive something because of where I drew it. So I get x squared equals 17 squared minus negative 5 squared. So 17 squared minus 25 is 264. It's negative 5 squared. Negative 5 squared is positive 25. If you don't put it in brackets, it will tell you it's negative 25, which is not true. All right, good talk. 264 divided by 4. Is 4 the biggest? I think so. X equals plus or minus 4 times 66. So 2 root 66. And it's plus because I drew it. And so I know it's plus. Yeah? All right. Then we have our other one, which is pi over 2 and pi. That's quadrant this. So we get x equals, and it is right, x equals negative 3, y equals 4. But we have to draw it because it could have been y equals negative even though it was on the x, right? We have to watch ourselves. That negative sign can move. And on diploma they will. They'll put it on the wrong one. And then you fall for it, and then you'll be all set. Okay? And then r is 5 when we do the math, because 3, 4, 5 comes up a lot. And this is triangle y. So now we want cos x minus y, which is a formula off our formula sheet. And if you do not spot that when I do cos, sine, or tan, something minus something or something plus something, if you don't spot that's a formula on the formula sheet, you're going to distribute, and that answer will be there, and you will be wrong. So this is cos x, cos y, plus sine x, sine y. comes from the x triangle and y comes from the y triangle. So cos of x is cook extra rice, so it's 2 root 66 over 17. Cos of y is cook extra rice, negative 3 over 5. Sine of x is sine your resume, so negative 5 over 17. And sine of y is 4 over 5. So we're going to get negative 6 root 66 over 85 plus negative 20 over 85. And so we get negative 6 root 66 minus 20 over 85. And you can leave it like that, or if you decide to take a negative 2 out of the top, it still has to stay there. It's not canceling off the bottom. So some people do take a negative 2 out, but they try and cancel it off. Can't. It has to come out of all three to cancel. So you take negative 2 out, and you're left with 3 root 66 plus 10. But then it sits in front. So both of these are correct, but you can't just cancel that 2 out. Yep. That is your answer. There will be one of these. Don't be like, oh, I hope there isn't.
Oh, I really?
Stop hoping, because there will be. There will be.
Just like a good chance I can get this.
All right. Sine of y equals 7 over 25. 0 degrees is less than or equal to y is less than or equal to 90. Determine sine 30 degrees minus y. So, sine your resume, 0 and 90, which is nice because y equals 7, r equals 25. What does x equal? Pardon? 24. And it's positive because it's in quadrant 1. Will they usually be that nice or me be that nice? Not usually. Okay, so we get sine of 30 degrees. Cos of y. Do you think they'll have the answer to sine 30 degrees minus sine of y as one of the answers? They're absolutely going to have one. It's picked often more than the correct one. Okay. Minus cos of 30 sine y. Sine of 30 is a half. Cos of y is given, no, it's not. 24 or 25. Cos of 30 is 3 over 2. Sine of y was given to us, 7 over 25. So we get 24 over 50. And then a lot of people are like, oh, I'm just going to reduce it. No. No. Don't reduce until you've done the whole thing, because they have common denominators, and if you reduce, you've destroyed that. Minus 7 root 3 over 50. So it equals 24 minus 7 root 3 over 50. Okay, one more, then we're moving on to radicals. No, that's not how it works. Some people's children. Okay, prove. So first step is to just rewrite it. There are different ways you can do this, but the fastest way I'll show you. So this is written like this, but I can rearrange the formula. I know whenever there's a sine squared x plus cos squared x equals 1, so I'm going to rearrange it. Sine squared x plus cos squared x minus tan x. And I know sine squared x plus cos squared x is 1, so I get 1 minus tan x. All right. Now this one here is literally one step away. I need to get to be 1 minus tan x. So remember that when you have a common denominator, you can always put them together as a common denominator. The catch you have to remember is you can also separate them. So for example, if I had 4 over 5 plus 3 over 5, I could write that as 8. Oh, whoa, no I couldn't. I could write that as 4 plus 3 technically over 5, right? Can I not? So I can, if I can go this way, I can also go this way. I can come back. If something's over denominator, I can write each of them separately over that denominator, correct? So watch this. I can go cos x over cos x minus sine x over cos x, which is 1 minus tan x. Boom. So we're taking it to our calculators, y equals square root of x. Remember like how the y equals x squared is the parent function, 0, 0, 1, 1, 2, 4, and that's your basic x squared graph. X cubed is a basic graph, x4 is a basic graph. So does the square root function. So when you type it in, it'll show up eventually, you get this graph that's sitting here. So it goes 0, 0, 1, 1, 4, 2, 9, 3, etc. Because what you're doing is you're inputting an x and you're rooting that x to get the y, correct? Because your equation is y equals root x. So 0, the square root of 0 is 0, so I get 0, 0. 4, the square root of 4 is 2, so that's how I get 4, 2. 1, the square root of 1 is 1. And we have to start at 0 because I can't do square root of negative 1, right? I can't do square root of negative anything because it doesn't actually exist. I don't know what you're doing. I just want you to print this part. Okay. So we have 0, 0. Need a marker. 0, 0, 1, 1, 4, 2. Now 3 and the square root of 3 is 1.78, so it does get you other ones. Like it's not just perfect squares. Square root of 8 is here, square root of 9 is 3, square root of 10 is a little more than 3, you know what I mean? And then that's your parent function, that's your y equals root x graph. So this is the one that we're going to be moving. It has an x-intercept of 0, y-intercept of 0, it has a domain of x is greater than or equal to 0, because you can't have negatives under the square root. And it starts at 0, 0, so it actually has a range of y is greater than or equal to 0. The intercepts and domain and range suggest there's an endpoint at 0, 0. The graph is shaped like half a parabola. The domain and range indicate that half the parabola is in the first quadrant. Then we talk about transforming radicals. So same thing, your original is root x, and then you still have the root x stuff, so anything that's under the root affects x's. So this would be a vertical stretch or reflection in the x-axis, vertical translation, horizontal stretch, horizontal translation, right? Nothing crazy. And it goes through just explaining those transformations. Okay, let's look at this one. Explain how to transform the graph of y equals root x to obtain the graph of each function. State the domain and range in each case. Show mapping notation and graph to new graph. So we need our original graph first. It's at 0, 0, 1, 1, 4, 2, our parent function, 9, 3, and it curves like this. That was a terribly drawn line. Flipped up. Come on. It's just frozen at this point, and it's not gonna. You did not freeze on me. Hi, Jerry. Yeah. Okay. So we have to give the transformations. We have a +1 in front of our x, so that's a good thing. Yeah, that's good. If they have room, if they don't, do they have room? Do you know? If they don't, find a spot. Okay. So here we have a vertical stretch. Actually, I don't think they do. I think they're full period. 1, 2, 3. Vertical stretch by a factor of 3 about the what? X-axis. Is there a horizontal stretch? Is there a horizontal stretch? No. Is there a reflection? Yeah, it's under the square root with the x, so it's a reflection in the y-axis. And then we have a vertical translation. Two units what? Down. And a horizontal translation. Four units what? So we want to move coordinates, and we want to move coordinates, we use what? Mapping. So x, y becomes negative x minus 4, comma 3y minus 2, and we plug in our coordinates. So our one coordinate is 0, 0. So the only thing that's going to affect it are the translations, right? Because when you multiply, which is the stretch and the reflect, it's not going to do anything. So my new point is going to be at negative 4, negative 2. So it's there. Then I use 1, 1. It's going to become negative 1 minus 4, comma 3 times 1 minus 2. So negative 5, 1. What the heck? It's going this way now. Should it be going that direction? Yeah, because there's a reflection in the y, right? Instead of going up and to the right, it's now going up and to the left. Because that reflection in the y makes it actually go the opposite direction. Then we have 4, 2. It becomes negative 4 minus 4, comma 3 times 2 minus 2, which becomes negative 8 and 4. And then we have 9, 3 becomes negative 9 minus 4, comma 3 times 3 minus 2, which is equal to negative 13 and 4, which is off. So we sketched it, right? Now the way that I sketched this, how do you know which graph is which? That's why you like it when they go f of x, g of x, which they didn't do. So the only way you can show that is you can go y equals root x on this one. And then on this one, you'd have to write y equals 3 root negative x plus 4 minus 2. Right? You guys try b. What are you going to have to make sure you do with b? Take out that 4. Okay, so we have to remember to take the 4 out. So we're left with 4x minus 3 plus 5. So we have a vertical stretch by a factor of 2 about the x-axis. And then we have a horizontal stretch by a factor of 1/4 about the y-axis. We have a reflection in the x-axis. A vertical translation 5 units up. And a horizontal translation 3 units right. So we have xy becomes 1/4 x plus 3, comma negative 2y plus 5. Y's always stay the same, x's be crazy. And then we use 0, 0 becomes 1/4 of 0 plus 3, negative 2 times 0 plus 5. So our starting point will always be the translation, because when you start at 0, 0, no matter what you multiply by, they're not changing. Okay? And then we have 1, 1 becomes 1/4 times 1 plus 3, comma negative 2 times 1 plus 5. So 1/4 plus 3 is 3.25, comma 3. And then we have 4, 2 becomes 1/4 of 4 plus 3, negative 2 times 2 plus 5, which becomes 1 plus 3, which is 4. The negative 4 plus 5 is 1. I put plus sign, you're welcome. And then 9, 3 becomes 1/4 times 9 plus 3, comma negative 2 times 3 plus 5. 9 divided by 1/4 is 2.25 plus 3 is 5.25. And then negative 1. So we get 3 and 5. We get 3.25 and 3. We get 4 and 1. 5.25 and negative 1. So it's down and to the right, which makes sense because I have a reflection in the x-axis. So instead of up and to the right, it's down and to the right. I have no idea. All right. C, we have to take the 5 out. X plus 1 minus 4. I'm just going to read the transformations because I'd like to finish this before we go. So the transformations would be a vertical stretch by a factor of 4 about the x-axis, a horizontal stretch by a factor of 1/5 about the y-axis, vertical translation 4 units down, horizontal translation 1 unit left. Our mapping would be xy becomes 1/5 x minus 1, 4y minus 4. So we get 0, 0 is going to become 1/5 times 0 minus 1, and then 4 times 0 minus 4. So like I said, it just becomes the translations. So negative 1 and negative 4. Then we have 1, 1. It's going to become 1/5 of 1 minus 1. I don't know why I just put a bracket there. And then 4 times 1 minus 4, which becomes 0.2 minus 1, so negative 0.8. And then 4 minus 4 is 0. And then we do 4, 2, which becomes 4/5, well, 1/5. I'm getting ahead of myself. 1/5 times 4 minus, 1, comma 4 times 2 minus 4. So 4/5 is 0.8 minus 1 is 0.2, negative 0.2. 8 minus 4 is 4. I'm really squishing this baby. And then 9, 3 becomes 9 1/5. Anyways, I'm going to do this. So I can finish the other one. Something like that. Okay. Then the other one, we have to take a negative 3 out. So we have to get x plus 2. And instead of it being up and to the right, I'm expecting it to be down and to the left because I'm reflecting in both, correct? So reflection in the x and y axis, horizontal stretch by a factor of a third about the y axis, and a horizontal translation 2 units to the left. So I'm going to get xy becomes negative a third x minus 2 comma negative y. So 0, 0 is going to become negative 1/3 times 0 minus 2 comma negative 0, which is negative 2, 0. And then 1, 1 becomes negative a third times 1 minus 2 and negative 1. So negative 7/3? No. Yeah. Negative 2. Negative 2/3. Negative 3.363.